And with this, really heading fast over to Martin Noble. You know him already from last year's adaptTo, where he also had a lightning talk. So, yeah, stage free for Martin. Thank you.
Cool. So everybody can hear me. So I am going to attempt to share the right thing. So hopefully you can now see my BBC Micro. So last year I gave a talk about a breadboard computer that I built, and I'll share a link to that in the chat later in case you haven't seen it. But I thought I'd go a little bit more up to date and a bit more powerful. So I've now got my BBC Master out. So I'm going to start my presentation. So I just need to load this. Just load up my presentation. Hopefully I can get the colour. There we go. So I thought I'd give a talk on 40 years of the BBC Micro. I actually gave this talk 10 years ago when it was 30 years of the BBC Micro. I'd forgotten that basically I was born the same year that the BBC Micro came out, and I kind of grew up. This was the computer that I first learnt to program on, and I had my first experiences of computing at school. So I was part of the BBC Literacy Project, which kind of they use these computers to teach kids about computing and sort of get you into this whole new world. And kind of strange to think of a world before, mainstream computers. But I thought I'd give a little bit of a history. So the sort of timeline of the BBC Micro, 1978, the Acorn were actually formed. They were originally called the Cambridge Processor Unit, or CPU. But then they kind of came up with the name Acorn Computers when they launched the Acorn System 1 in 1979. And so they basically called it Acorn because they wanted to kind of have the idea that it was something that was going to grow, it was expandable, and sort of that idea of growth and expansion over time. And then in 1980, they kind of got a bit more complicated. They launched the Acorn Atom, and that's the first computer that they launched, which really looks like what the BBC Micro would become. And then in 1980, the BBC, there was a documentary on ITV in the UK about microcomputers, and the BBC suddenly realised that they needed to do something microcomputer related, and they wanted to do a TV series about microcomputers, and they wanted a computer to sort of go along with that series that they could then get people to buy, and they would be able to follow along and do the same things, and they could also get it into schools and then sort of have that as the sort of standard computer in schools. And so they started this project, and they originally, through some possibly slightly dodgy dealings with government departments, selected a company called New Brain to build it, or they selected a thing called the New Brain from Newbury Labs. But it turned out that they really weren't going to be able to deliver the thing, and so they basically then put it out to tender properly. And there were two real contenders. So there was Acorn and obviously Sinclair. So they had sort of the Spectrums and things like that coming along, and very similar machines. But in the end, the BBC, what would become the BBC Micros, at that point was called the Proton, was kind of the follow-up to the Atom, was the only one that really met all the specs. And the big thing that it did that the Spectrum and things didn't do was the expandability. So the Micro is really expandable. In particular, it's got a thing called a tube port, which is basically access directly to the system bus, and that enables you to plug in coprocessors. And so you could actually, even though it's got a 6502 processor in there, you could plug in a coprocessor unit, which would basically replace the CPU with like a Z80, or even later on with an 80186. And so you could run things like CPM and DOS. And one of their big requirements for BBC was that you should be able to run CPM on the computer, and that's something you definitely couldn't do on things like the Spectrum. And so they eventually gave the deal to Acorn. And 1981, two amazing things happened. Obviously, the BBC Micro was born, and I was born. So I was born in October. The BBC Micro was born in December. So I'm slightly older than the BBC, but only by a couple of months. And then they originally wanted to air their program in sort of autumn of 1981. They ended up shifting it into early 1982 because the computers just weren't going to be ready because of this being let down on their first selection. So eventually they did manage to bring out the micro in December 1981, but really didn't ship many. And so most of them shipped in 1982, and the computer program aired throughout 1982. And eventually in 1984, they won the Queen's Award for Technology, basically for getting this computer into the hands of children, into families and things like that. But what was kind of happening in the background was it all went a bit wrong for Acorn, because they kind of kept expanding and they kept making new things, but things had kept going a bit wrong. Part of the problem was the price, because the micro was about I think it was £300 for the at that time, which I think comes out as something like, in today's money, is more like about £1,000, which was a lot of money for for home to build. And the BBC and schools got a big discount on that, but it was still a lot of money. So then they came up with the idea of making the Electron, which is basically a cut down version. They tried to do that then for Christmas in 1983, but they basically missed the boat because they couldn't get the chips made in time. And so they were hoping that people would then wait and then would buy it in 1984 when they could do it. But the reality is everyone went and bought C64s and ZX Spectrums because they were available and people needed a computer for their kids for Christmas. So basically in 1984, they ended up with about 100,000 Electrons and 40,000 BBC Micros just sat in warehouses, not sold. And for odd reasons, they wouldn't do things like discounts and things like that. And so in the end, in 1985, they end up basically £30 million in debt, and they end up basically selling most of the business over to Olivetti, and then all sorts of things go on, and then they sort of fade into the background. But the BBC Micro is still something which is it particularly in the UK is something that a lot of children people of my age really will remember, because it's the first computer you had in school. So a bit about the specs of it. Oops, my camera's has dropped out. 1 second. Hopefully that's back. So the specs. So the BBC Micro, so the Model A and B is a 6502 processor running at 2 megahertz, 16K of RAM in the Model A and a whopping 32K in the Model B. Both of them had 32K of ROM. So you got the operating system 16K and then the 16K for basic. And then, you could do a lot of them. Initial ones, you'd only really have tapes, but you could have disk drives. Even, you could go crazy and have hard drives. But the reality is hardly anyone had hard drives, because, a Winchester hard drive of maybe 30 megabytes was probably costing you, back then, I think I looked it up, their price sheet showed about, I think it was about £1,800, which would be about £5,500. And that's for 30 megabytes of storage now. And so that's kind of, not many people really did that. And then obviously in 1985, so a bit later, they continued sort of expanding. They basically made the BBC Master, which is what this is actually running on. The big difference being the BBC Master has 128K of RAM, so you can do a lot more. And it's actually got a 65 SC12 processor, which is effectively a CMOS version of the same processor, but it's got a few additional instructions. In theory, anything you wrote for a BBC Micro could be run on a Master. The reality is some stuff just doesn't work because people used hacks and they used specific memory addresses and things which then wouldn't map across correctly. Then one of the last things is just about screen modes. So this is kind of showing just how little space you actually have, or what you have to play with graphics wise. So you've got 7 screen modes. The ones where they say none for pixels are basically text only modes. So mode 3 and 6, you can do graphics, but they do a weird thing where they put additional lines of space in to sort of fill in the gaps, because they basically have take up less RAM for the same amount of characters, so they effectively double space things up and things. And so a lot of them you can see taking up sort of 20K of RAM, so it's a lot of your memory going just straight into video stuff. But that's why some games will actually make use of mode 7, which is actually what this slide deck's running in, which is teletext mode. And you can basically have the full 40 by 25 character screen, but with only a 1K of memory. So you get all of the rest of the memory for whatever you want to do. So particularly on the BBC Model A, that's particularly good, because then you can actually use all of the memory to do whatever you want. And then you can actually do quite a lot of interesting stuff with the teletext characters and things like that. So you can do, as you can see, double height fonts and things like that. Lots of games made use of graphics characters and things, so you could actually build shapes and pictures. And the last thing I wanted to just quickly show is just loading up a little demonstration of this is actually some of the graphic sort of stuff you can do. This is actually a program running in BASIC, which is basically the worst possible way you can do graphics on a BBC because it's really, really slow. You can see just how slow it is at actually drawing all of these pixels. So that's about as fast as it can actually draw these pixels to the screen. But then you can use some funky graphics switching to do what actually looks like it's doing crazy sort of rendering. What it's actually doing is fiddling around with the colors. So all it's really doing is controlling which of those pixels is visible at any time. And it can do that fast enough that you can make it look like you're doing animation on the screen. So those are some of the tricks you could do without having to delve into the complications of writing machine code routines to do graphics, which then is kind of the next level if you want to do actual fast graphics, is to go into machine code. So there we go. So yeah, back to you, Stefan.
Yeah, great. And the first adaptTo, we can finish real fireworks.
Well, I thought I'd end with a bang.
Yeah, and I love your retro interpretation of the adaptTo logo. We should handle.
Yes, well, yeah, and that's about as good as you can get to adaptTo logo in teletext fonts.
Yeah, great. And if we are on it, my first computer, I can put to a quick sharing here. It was a Sharp Pocket PC 1500A, also basic, but you have only one line of code. A bit challenging to do a complex program with only up and down arrows.
Yeah, you're going to struggle to do fireworks on that one.
Yeah, but you could use the printer around it. This is only the printer, and the PC is only this one. So you could use a printer to draw things in 4 colors. Yeah.
Oh, well, there you go.
Okay. Fine. Great. Yeah. Thanks a lot for all your 3.